All right, and let me get my pen up here. And let's go with a nice red there. All right, cool. All right, so first question is check all boxes that represent molecules. I think most of it, this question, a lot of you got correct. Some of you had a few outliers there, but basically what we see here is we know that this is definitely a molecule, the carbon dioxide. The nitrogen, which has 2 nitrogen atoms, is a molecule. The oxygen is a molecule. And we see this water is a molecule as well. So most of us got that right. I think there are a few people that circle maybe some of the other ones or clicked on the wrong ones. But if you check those boxes, you're good for that one there. Okay. On to the next question. Next question is about atoms. Which boxes represent atoms? And we can see here that we have oxygen as a single atom. Argon is a single atom. We have hydrogen as a single atom. Carbon and nitrogen. So if we check those boxes down here for those particular answers, we got that problem correct. Okay, so that's how we did that one there. All right, looking at the diagrams in 1 and 2. So I'm just looking at these diagrams 1 and 2. What level are we examining? And so in our world, I know a lot of the stuff that we've been doing has been in this macroscopic world, especially like the demonstrations and things like that. We sort of skipped the microscopic world. I know there were some people that said, use a microscope to see what's changing in our matter or how our matter is moving. But really, we kind of skipped that level, even though we do use that level a lot when we talk about cells and looking at different things in organisms. We really, when we're talking processes, we're really going to jump down to this level. So if you answered atomic molecular, you got that problem correct. All right, and then we get into the kind of the 2 problems that we do spend some time on, but we want to get, right away we want to get into this. And if you wrote down the rules for atoms, and if you recall that, remember that atoms they don't change, they just exist. Atoms stay the same forever. So this problem right here where it says all the carbon atoms that exist today in CO2 will still be carbon atoms in 1 million years. That is true. So atoms do not change, remember? And so we know that that's a true statement in that case there. The next question, though, and when we look at our responses, I can't turn that off here, but when we look at our responses, about 50% of you said that this question was true. And that is this question, the answer is actually false because some CO2 molecules could change. Now, what I want you to think about is how could a CO2 molecule change? There is a process that occurs, very important process on Earth, that if it didn't occur, we probably wouldn't be here. So there is a process that actually takes CO2 and changes it into some other molecules. So that's something that we'll look at, but think about that. What process is it that would actually change the CO2? So there's a good chance that CO2 molecules could change. They're not all going to stay the same in 1 million years. So this answer to this one is false. Molecules can change. All right, we get on to the next one. Which molecules found in air do not go into the flame when ethanol burns? So we had a lot of good answers to this one. A lot of people were correct, but we had some people that had a lot of different things going on. So again, the key thing in this question is does not go into the flame. And when we look at this, we know that there's only one thing that really goes into the flame. Whenever we burn something, those of you that have had chemistry know you need oxygen. So these other molecules that are in the air do not go into the flame. So if you checked off nitrogen and argon and CO2 and water, you are correct. These things do not go into the flame in the Petri dish. So remember our Petri dish we have here, and we have our flame, and we're wondering what things out of this go into that. And in this case, these things do not. None of these do. The only one that actually does is this one right here, would go into the flame. Okay. All right, so let's go down to the next one here. which molecules found in air exit the flame when ethanol burns? And so what here's your petri dish, okay? And we know we have our flame. And so we want to know what is coming off of that is in the air. And most of us know, and most of us got this correct, that there is only one thing in the air that exits this flame. Well, actually two things. If you answered it correctly, there's actually two things. Carbon dioxide, most people wrote that down. Okay, so most of you had that. But there's actually another molecule that does come off the flame. You wouldn't, and we'll be able to examine this and prove this later on, and that is water. So if you had both of these, you were correct on that one. I'm not sure how many of you had both. Again, these are all false there. None of those would be exiting the flame. This one, remember, goes into the flame. So that was that one there. All right, then this last one was an optional one. We had a lot of different answers there. What atoms do you think are in ethanol? Going back up to this one here, since we know that by now, if I scroll this back down, we know that oxygen, O2, is going into the flame. And right now we know that CO2 should be coming out. We're going to be trying to prove this today. And this is where when you watch the BTB video with Ruby, that should help you. So if CO2 is coming out, but O2 is coming in, where is this carbon coming from? And a lot of people did put that down in that ethanol. And obviously you could Google that and see what ethanol is made out of. But a lot of people understood that ethanol definitely has carbon in it, and it also has hydrogen and oxygen. So if you put those three elements down, you are correct. So next, go ahead and watch that video of Ruby with BTB. It's important to understand what BTB is. We're going to be using that substance for our next experiment for next week as well. Check it out. There's a question that's posted to answer for that, and we'll see you on Friday. And Friday we'll probably have another forum for you to answer some questions, or might show you some things that are going on in Captain Kirk's lab, some other things that are going on down there. So otherwise, have a great day and stay safe. Thank you.